Okay, so let's go to the project initializer. We're gonna choose Kotlin as a language, JDK 21, and the newest Spring version at this time. Gradle will be our build system, and the only two dependencies we're gonna add are Reactive Spring Web and the Oauth2 client. The Kotlin coroutines are added by default. We're gonna need them later. The next thing is to create Google Cloud projects. The link will be in the description. Once you have the project created, navigate to Credentials and click on the Create Credentials button. Choose Oauth Client ID, and as the application type, choose Desktop App. Copy your client ID and client secret. You can also download the JSON file with those values. The next step is to set up the properties. So you need to copy paste your client ID and your client secret. Let's create a simple endpoint. As you can see, we are redirected to the login page by default. This is because all the endpoints are protected. Let's inject token object so we can send it to the client. As you can see, there is a lot of information here, but mostly we are going to focus on the attributes. Now let's debug the tokens to see how it is structured as an object. There is a nested object principal, and the type of this object is default OEDC user. Let's look closer what's inside. As you can see, it extends default Oauth2 user. And this is what we need to extract the map of attributes. Let's map the attributes to our custom Google user. To make it happen, we need a data class and extension function for our token. As you can see, the data is duplicated, and this is the matter of the library and the Spring implementation, so there is nothing we can do about it. Let's focus on claims because this is the standard naming convention for JSON Web Tokens. As you can see, there is a data associated with the Google account, like email address and the profile picture. Let's proceed and map the rest of the data to our custom object. And we got an error. So let's see what went wrong. Okay, so there is a null pointer exception. It's understandable, and this is because there is no such attribute as ID. It's called sub. There is also another mistake. There is no avatar. It's a picture. As you can see, everything was mapped as expected, but in real case scenarios, sending a token to a client is not a smart choice, I believe, because it can result in hijacking a session. But this is just an example, so let's keep it for now. Okay, so this is a full project that is available on my GitHub. And as you can see, it contains more example endpoints, as well as some filter for authorization of an endpoint, which is optional to use. There are also more client providers, so you can log in not only with your Google account, but also with a GitHub and Facebook. However, using Facebook is not that easy because you need to create a business account and you need to provide them a business justification for your application, as well as some very detailed form including your home address and other personal data, so I will not cover this in this tutorial. The full project also uses more coroutines, and it also has database connection using R2DBC, which is non-blocking and asynchronous. We are not operating on Mono and Flux directly, but we are using async await model, kinda similar to what you have in JavaScript, which in Kotlin is just suspend and await keywords. There is some usage of good old Spring repositories, as well as DB client provided by R2DBC, and a very simple database schema to make some queries to embedded H2 database. The properties are straightforward, so it's quite obvious where to put new client ID and client secret to use other authorization servers. Let's run it and let's try to log in with GitHub this time. As you can see, it worked, and as a result we received an ID which is equal to your GitHub account. I mean the login basically. And there is also other common data that was shown in the previous example, like the profile picture. Let's try out some basic endpoints, like listing the users that are stored in our embedded database. Okay, my mistake. I forgot to use API prefix in this path. And the list is empty for now, but let's add some user to the database. To do this, we need to call the save user endpoints. And yes, I'm using get mappings for every endpoint because I want to make it easy to test in the browser. This endpoint will take the user that is currently logged in and store some information in the database, like timestamp and the location based on the browser settings. Okay, the user has been saved, and as you can see, the country is US, which is false because I live in Europe, but it's probably my browser. And now let's go back to the API/user users, and if I refresh this endpoint, I will receive the list that contains exactly one element, which is the user I have just saved. Check out the README file for more details how to set up the authentication with Google and GitHub. For the GitHub, you need to follow the link, which is /settings/developers, and here you need to create new OAuth application. As you can see, I have already created mine, so once you are done with yours, just open it, and here you need to set up the two values that are very important. One of them is homepage URL and the other is authorization callback. For the local development, you probably don't have any DNS address, so just set those two values to localhost like I did and you should be fine. I highly recommend to use Kotlin over Java, especially in WebFlux applications. Async model and coroutines help us to escape from the mess of Reactor API. It is not only easier to read the code, but also to debug it due to its imperative structure. If you want to learn more, you can start with Kotlin docs. The documentation is well written and you will find there a lot of information about coroutines. Pay attention to the section about dispatchers and threads. Understanding these key concepts will help you to write more performant code. You can also check out Spring docs to read about coroutines and how Kotlin flow is translated to Flux. That's it for now, and see you.